Hi, in this video we're going to turn our attention back to function parameters and function arguments. So first let's just recall from iterable unpacking what we saw. We can unpack an iterable on the right hand side into a tuple on the left hand side, and we just get positional mapping. So we get a equals 10, b equals 20, and c equals 30. Now something very similar happens when you call a function. So we can first define a function with three parameters a, b, and c, and then we can call it using these values as arguments, 10, 20, and 30. And essentially it's going to be as if we were unpacking this tuple 10, 20, 30 into the variables a, b, and c, which are the parameters of the function. And so we end up inside the function with a equals 10, b equals 20, and c equals 30. So it's very similar to iterable unpacking. In fact, it's so similar that it also supports the star expressions. So let's just recall from iterable unpacking how that worked. If we had a, b, star c, that meant take any iterable on the right hand side, take its first element, put it in a, take the second element, put it in b, and then any remaining elements go into a list that's going to be called c. And so here we end up with a is 10, b is 20, and c is the list a, b. Of course, if we had nothing after the 20, this would just be an empty list. Now something similar happens when we use positional arguments that are being passed to a function. So for example, we could define a function with these parameters, a, b, and star c. And that essentially means that we will be able to accept two or more parameters when we call func1. So we can specify two or as many more as we want arguments when we call func1. And for example, we could call func1 with 10, 20, and then these two extra positional parameters, a and b, right? Actually, technically arguments, a and b. And so a will be 10, b will be 20, and then c will collect the rest of the positional arguments. And c will end up as a tuple, a, b. So note, though, that this is a tuple. It's not a list, unlike what we had when we were doing iterable unpacking. We do end up with a tuple. That's kind of a minor difference. Now, the star parameter name is arbitrary. Here I used star c, but you can make it whatever you want. And it is customary, but it's not required, just customary to name it star args. You'll see that that's a fairly common convention that everybody uses. We just call it star args. But in reality, you can make it whatever you want. The name is just the variable name. What makes this special is the star, just like we had with iterable unpacking with the extended unpacking. So for example, in this case, we would probably write it as def func1 a, b, star args. Now star args exhausts the positional arguments. This is a little bit different than iterable unpacking. So you cannot add more positional arguments after star args. That's what I mean by it exhausts the positional arguments. So let's see what I mean by that. Well, we could define a function this way with these parameters a, b, star args, and another parameter that comes after that. But if we try and call the function, this will not work. If we try and call func1 with 10, 20, a, b, and then 100, Python is going to complain saying, no, you cannot pass a positional argument after basically this has exhausted your positional arguments. So that will not work. And we'll rectify that in the next set of lectures. We'll take a look at something else that allows us to do that. But for now, when we're using positional arguments, we can't do that. And we'll see that in the code example. So writing this is actually okay, right? Defining a function with this style of parameter list is fine. That's perfectly acceptable. That works. But it doesn't work in quite the same way that we would expect with iterable unpacking, right? Where this would just take the last element of the iterable, and then it would take the first and the second. So it would put 10 into a, 20 into b, 100 into d, and then star args would be the remaining, which would be a and b. It doesn't work that way in functions, because after we've exhausted all the positional arguments, we get something else, which we've seen before actually. They're called keyword arguments. We'll get to that in the next lecture. So as far as unpacking arguments go, suppose we have this function. We have a function, again, one that just takes three positional parameters, a, b, and c. And suppose we have this list with three values, 10, 20, and 30. And we essentially want to pass 10, 20, and 30 as the arguments of this function. Right? We have three parameters, we have 3 elements here, so we should be able to get 3 arguments. But this will not work. If you try and call func1 and pass it the list, it's going to say, no, I'm expecting 3 positional arguments, you only passed in 1. So we can't do that. That's not going to work. However, we can unpack the list first and then pass it to the function. And again, we've seen that when we're unpacking iterables. Now this is really just iterable unpacking, but it's iterable unpacking on the right-hand side of the assignment, if you remember. So we can call it this way. We can say func1 star L. So first unpack the list and then pass it to the function. And that will work just fine. And inside the function, we'll have a equal to 10, b equal to 20, and c equal to 30. All right, let's switch to some code and let's take a look at that in more detail. Thanks for watching, and I'll see you in a bit.